the Middle Age, the sword wasn't the most powerful weapon available, but it was a very convenient self-defense tool, and so it was very common to bring it around and to use it. The slash in 42 covers about the same role. It's not the most sophisticated or powerful tool available, but it's very convenient. For example, where in Java you will use a lot of streams and lambdas, in 42 you just use the slash. You're going to use a lot of slashes for exactly the same reasons. But wasn't the slash just a way to avoid writing down the receiver or the expected type? So how can it serve the same role of streams in Java? Well, that was a great discovery also for me. Like, I didn't design it, it just emerged. You see, in 42, you can have methods that take void arguments. Marco, please make a consistent explanation how the void type can possibly be connected with the slash and the streams, and why you may ever want to have void as a type argument. Well, in most languages, void is like a special type that you can only use as a return type. Instead, 42 is more consistent, and you can use voids everywhere your type is expected. Yes, but what's the point? How can a void argument serve any purpose? Well, 42 is an expression-based language, and if, while, and for are expressions of type void. Yes? And so? So, we can have a method that takes a single argument of type void and is doing nothing with the argument, but we can use the slash to represent the receiver of the method. And so, here we can have our AS with the numbers 1, 2, 3, 4, and then we can have our BS0 as num.list open close, and this is just creating an empty list. So if we don't put elements, we can use open close or square brackets. Go to the point! Yeah. So we create a new list, num.list open close, that is an empty list, and then we call the apply method, the method without name, that takes a void that parameter. And so we can write a bunch of statements inside of it, because the statements have void type. In particular, I can write a for, and so I can do for a in AS slash add a multiplied by 10. That is, the slash remembers the receiver of this method call, that is, the new list. And so by doing slash add, we are adding an element to our list. Once we have completed the for, we have added all the elements to our list, and the method concludes. And this very weird method without the name that takes a void argument just returns the receiver. And in this way, we are just doing a mapping. So instead of using streams and lambdas, we can create a new list that is obtained by iterating over other collections just by using this method. So we have seen how we do a map. Let's see how we do a filter. That is, we want to iterate on a collection and select only a part of the elements. So bs1 equal num.list, that is the empty list, and then we call the same exact method without name that just take a void argument, and we do for a in AS, if a is bigger than 2, slash add a. That is, again, the slash is remembering the collection outside, and so by doing a for with an if, we make our filter. So we have seen how to make map and filter, two of the most iconic operations on Java streams. Let's see now how we can make a flat map. We can have bs2 equal numList open close to create a mutable empty list, and then we call our usual method, and then for a in AS, for b in bs0, slash a plus b. That is, there is a wide range of possibilities for our slash. We can have any kind of permutation of fors and whiles and if one inside each other as normal when we write statement, because we just have to put some statement there. This syntax with a slash is actually equivalent of writing 3 different lines of code. One where we declare the empty collection, one when we populate the collection, and one when we return this collection. So, in concrete, you see this one could be translated into this, where we take off this and we do BS0. But now I could not write him, right? Because BS0 is mutated here in line 5. So if I wanted to be able to promote the result, I will have to jump to 3 lines. So I can have, I don't know, temp, or no, much better, slash equal num list for a in AS slash dot add number slash. So as you can see, this is the expanded version. Without using the slash, we can still get exactly the same behavior on multiple lines. We first create the collection, then we have a bunch of statements that mutate the collection, and then we return it. Once you are used to code like this and you start to get bored of having to choose a name for your local variable, you can just use this fantastic tool and write it in 1 line. This same idea is very general and doesn't just work only for lists. For example, we can reduce to a string. So I can have a string, the content is colon, close, string literal, dot builder, open, close, open method without name, for a in AS, slash add a. And in this way, we are creating a new string where we append on the end of that string all of the elements of our list. In this way, we can have a string that looks like the content is colon space 1, 2, 3, 4. As an interesting exercise, let's see what it will take to replicate the behavior of the list to string, but with a comma instead of a semicolon. We could have a string that starts with open square bracket as.left.builder for n in as.vals1, that is, we skip the first element, that is the left one, because we already included it in our printout, and then slash add comma %n, and so we print the comma, the space, and the number. And then we close the round. This produces the string with the open square bracket and all the elements separated by comma. And then we just add the closed square bracket. Now, how do we make a more general fold? Feel free to do it manually without a slash if you want. You can do var x equals 0 num for a in AS, x plus equal a, return x. Perfectly reasonable. Or, if you want to be cool and use the slash, you can do 0 num dot acc, and this is going to create an accumulator object that starts from the number 0. And then, for a in AS, slash add a. And in this way, you just add all the numbers together. The accumulator have way more useful methods. There is slash add, but there is also slash times, and you can use slash val to get the value out, or slash val with a parameter to directly set the value of the accumulator. That is, it's exactly like the line above, where you declare your local variable x, but you don't have to define a name for this local variable. You just use the slash. With Java streams, you can also do things like any match, where you can check if there is any element in the list that match a predicate. And we can do exactly the same here with a slash. So I can have match.sum, that is a matcher object, that will be satisfied if at least one element matches a predicate. And we can encode this without the need of any lambda, simply writing match.sum, open, close, open, for A in AS, slash add A bigger than 3. That is, we use a Boolean expression instead of a predicate, and add method will be satisfied if we get a true, and it will not be satisfied if we get a false. That is, if the method add is satisfied, it's going to throw a break and stop our for. In this way, our match sum is going to run only until we found the first element that match. This match syntax is very convenient as the top-level body of a method or inside of an X. So, for example, if you want to check that it's not the case that all of the elements are bigger than 3, you can just do this. X square bracket not match all for A in AS slash add A bigger than 3. And you can do the same for match none. With the accumulator, you can also add conditionally. So you can have 01.acc for A in AS, add 1 to our count if A is bigger than 3. And so we get to be equal 2, that is, there are two numbers that are bigger than 3. An interesting application of our match all, match sum, and match none is that they can be used to represent contains all, intersect, and disjoint. Look how easy it is. If we have a list AS and the list BS, we can check if AS contains all the elements in BS just by doing match all for B in BS, add B in AS. That is, if this check is always true, our collection BS is fully contained in AS. Two collections have a non-empty intersection if there is some elements that is in one and the other. And so we can just write match sum for B in BS slash add B in AS. And then two collections are disjoint if there is no elements that is in both of them. So we can do match none for B in BS slash add B in AS. That's all for today. Next time we are going to see lists where mutable and immutable elements can coexist at the same time.